We're going to talk today about identifying quadratic functions. There's some vocabulary that you need to write down, and make sure that as you go through the video that you have all of these words. You might want to pause the video right now to write down these words. All right, this is a function, y equals x squared. Remember, when I'm telling you a function, you know that it meets all the parameters of being a function. You'll notice that it's not linear. This graph is not a straight line. This function is what we call a quadratic function, and we're going to learn several different ways to identify a quadratic function. The first one is any function that can be written in standard form of, and you'll see it written here, but I'm going to write it for you again, y is equal to ax squared plus bx plus c. Now, the secret here is the x squared. That's what makes it quadratic. It tells you that a, b, and c are real numbers, and a is the only one that cannot equal 0. Now, the reason for that is if a equals 0, then you don't have the x squared part of this, and therefore it is not a function. So, in this particular one right here, y equals x squared, a is 1, b is 0, and 3 is 0. And that's what a quadratic function looks like when you graph it. But again, for this part right here, we're saying that any function that can be written in this standard format is quadratic. All right? When we were talking about linear functions, we saw that there was a constant rate of change in the x values and the y values. We called that an arithmetic sequence. That is what we call a first difference. So when you see it right away, the very first time you do it. With a quadratic function, we see what's called a second difference. So let me show you. With the x values, we still see the constant change, an arithmetic sequence with our x values. With our y values, when we found the first difference, okay, so the difference between 0 and 1 is plus 1, between 1 and 4 is plus 3, 4 and 9 is plus 5, and 9 and 16 is plus 17. Is 16 plus 7. That's a first difference. If those had all been the same, this would have been linear, but it wasn't. So we're going to try it again, only this time the difference between the differences. So the difference between a 1 and a 3 is a plus 2. The difference between a 3 and a 5 is a plus 2. The difference between a 5 and a 7 is a plus 2. That's a second difference. If you can get them to be the same the second time through, this is quadratic. So let's take a look here really quickly. All right, ready? From here to here is plus 1, plus 1, plus 1, plus 1. So plus 1 all the way down. Okay, ready? From here to here is plus 7. From here to here is plus 1. From here to here is plus 1. And from here to here is plus 7. Okay, that didn't help us. Let's try it the second time. Between here to here is, minus 6. From here to here is nothing. From here to here is plus 6. That didn't work. So this is not quadratic. All right, let's try here. Ready? Plus 2, plus 2, plus 2, plus 2. Always make sure that you've got that with the x's before you bother to even try the y's. Okay? All right, then here to here is minus 6. Here to here, minus 2. Here to here, plus 2. Here to here, plus 6. All right, that didn't work. Let's try the second time through. Ready? From here to here is plus 4. Here to here, plus 4. Here to here, plus 4. Second difference works. This is quadratic. All right, so two ways that we've learned to do that so far. First of all, if it can be written in standard form, ax squared plus bx plus c, where a is not equal to 0. Okay, again, you don't even have to have this term or this term there. That's the part you've got to have, the ax squared. Okay, the second way is if there's a constant change in the x values and a second different constant rate of change in the. Pause the video and check to see, make sure that you've got the understanding right here. Tell whether these functions are quadratic or not. This one is not. It is linear, actually. This one is, if you add 10x squared to both sides, there it is in standard form. The a value is 10, the b value is 0, the c value is 9. And this one is, you'll see the second difference there. So just make sure that you can get those and you recognize those. Okay, when you graph a quadratic function, you get a shape that's called a parabola. Okay, and what you have to do is you have to graph enough points until you actually see the shape of the parabola starting to happen. Now later on we'll learn more specific ways to do that, but for right now just plug in enough points to make sure that you see that the shape is happening there. So here is an equation. Now you should recognize right away that it is quadratic based on the equation itself, but let's put in some x values. I put a -2 in here. This is the y value that I get. I just want to remind you really quickly, when you substitute a -2 in here, so when I put 1/3 times, this goes in parentheses, -2 squared, that goes in parentheses, because that -2 squared becomes a 4, and a 4 times 1/3 is 4/3. All right? So we put those in there, we make a table, we choose some values, and then we plot those points. So here's 5 points here. These are the 5 points that it plotted, and you'll see that if you connect those, you get that nice smooth curve looking parabola. Okay, so here's another one. You want to pause this. Make sure that you can get these. Again, remember this goes in here in parentheses. Okay, so we're going to make a table. Again, we're going to plot those 5 points. And again, you see the parabola. Start looking at the equations. Let's go back here for a minute. Looking at this equation, how this parabola looks. And then this one, how it looks a little bit different. Same general shape, but a little bit different. Let's try this one. You'll notice this one has a negative in front of it. So let's work this out. Make sure that those are correct. So choose a table. Ready? Plot those. Oh, look at that parabola. He went down the other way. It must have something to do with that negative sign right there. Okay, when it's written in this format, you can tell the direction that the parabola is going to open by the a value. A parabola opens up when the a value is positive, greater than 0. A parabola opens down when the a value is less than 0. You'll notice that never in here do we say that the a value is equal to 0, because we know that a cannot equal to 0. That is one of the restrictions. The highest or the lowest point on a parabola is called the vertex. All these vocabulary words flying in there. If a parabola opens up, then the vertex is the lowest point. We call that the minimum. That makes sense? Okay. And if the parabola opens downward, the vertex is the highest point. We call that the maximum. And again, lots of vocabulary words you need to make sure that you have. Okay, so here's some practice. Pause the video and then check your answers. Okay, with each one of these, I made sure that they were in standard form first, so I added 1/3 x squared to both sides. My a value is positive, so it opens up. Here, I just put them in the right one. Remember, this goes with the sign behind it. If you change this to plus the opposite, that's pretty obvious that it goes with the 3x squared. Since that's negative, since that a value is negative, it opens down. This one I threw in here because I want you to remember this is the same thing as y. So whether you see the function notation or the y, it's the same thing. Again, this a value is negative, so it opens down. And for the last one, I added 5x squared to both sides. The a value is positive, so it opens up. Okay, identify the vertex of each of these. Again, remember the vertex is the turning point. So this would be, let me get rid of these stray marks here. Oops. Okay, so this would be the vertex right here, and that is, the vertex is -3, 2. Since it's down here, this would be a minimum value. The minimum value here would be 2. This up and down, the y, is your maximum or minimum. So that part of your vertex is always your maximum or your minimum. And this one, your vertex is 2, 5. This is a maximum because it's on the top. And again, it's the y value. The highest point that it comes up to here is 5. Okay? So there's your answers down there at the bottom. Okay? Last thing is we're going to talk about domain and range very quickly. Remember, domain are the x values, range is the y values. Unless you are given a specific domain, for almost all the quadratics, you can just say that the domain is all real numbers. So we will do all real numbers. That's because these arrows go to the left and the right forever. You can look at the graph to find the range. Now again, the range is the y values. The range will always begin at the maximum or the minimum value. In this case, it is a minimum value. It is 1. So if it's minimum, it means it's the smallest. So that means all of your y values are greater than or equal to 1. Okay? So let's take a look at this one. Okay, again, your domain. Think about what we just said. Any real number. Your range is always going to start or end with your maximum or your minimum. In this case, it is a maximum, and it's at -3. So all of your y values have to be less than or equal to -3. And that is it.